When thinking about the chemistry of carbonyl groups, it's really important to separate acidic and basic conditions. For instance, Grignard reagents are quite reactive. They will add directly to carbonyl compounds. This occurs under basic conditions. However, water is not a reactive nucleophile, and to make that react with a carbonyl compound, we first need to protonate the carbonyl with an acid. Reactions of carbonyl compounds under acidic and under basic conditions are different. Protonation is required to activate aldehydes and ketones for the nucleophilic attack of water. Once the oxygen of the carbonyl group is protonated, the carbon becomes more electrophilic. When the water adds to the carbonyl group, the carbon of the carbonyl goes from sp2 to sp3 and we form a hydrate. The hydrate is called an addition product because the water adds to the carbonyl. There are no byproducts. It's just like sums. 1 plus 1 equals hydrate. Additions of alcohols to aldehydes and ketones is essentially the same. A protonation step activates the carbonyl. It becomes more electrophilic, and this time the oxygen of the alcohol, rather than water, adds and forms an sp3 hybridized intermediate. But there's a difference. To make this equilibrium reaction proceed in a forward direction, a proton has to be lost from the oxygen with the alkyl group on it, in this case a methyl, then gained by the OH group to make that a leaving group. This is called a proton transfer, and it's a very common concept in acid-mediated reactions of carbonyl compounds. Understanding proton transfer makes it much easier to understand mechanisms of aldehydes and ketones under acidic conditions. Let's take acetone for instance. Protonation of acetone and attack with methanol gives an intermediate which loses a proton and then gains a proton on the hydroxyl group. That makes the hydroxyl group into a leaving group. A lone pair from the O alkyl, in this case O methyl, is donated. Water leaves, generating an oxonium ion. That reacts with another alcohol. And finally, loss of a proton gives the final product. It's a ketal. Ketals are formed from ketones. The uncharged intermediate is called a hemiketal. Hemiketals and ketals are formed from ketones. Hemiacetals and acetals are formed from aldehydes. The ketone can be cyclic, so cyclopentanone gives 1,1-dimethoxycyclopentane, and the alcohol can be a diol like ethylene glycol or 1,2-dihydroxyethane. In fact, the two alcohol components and the carbonyl can be in one molecule. And that's quite a special reaction because one molecule generates two molecules. The equilibrium is entropy favored. Ketals of this type are thermodynamically stable because of that entropy factor. Intramolecular formation of hemiacetals is the way that acyclic carbohydrates cyclize. We'll learn about carbohydrate chemistry more in other videos. Bye-bye. If you're having trouble with this or any other concept in organic chemistry, please leave me a comment below and I'll try to help you.
Problems like this can be found in the workbook Sophomore Organic Chemistry by Inquisition, Volumes 1 and 2. These are available for $35 each from www.byinquisition.org, and the answers to both sets of problems are available on that website too as downloadable PDFs.